Thanks for having me here, everybody. It's good to be in Amsterdam and see everyone. Just a quick show of hands. Who here has ever heard of Deno before? Leave your hand up if you've ever used Deno before. Okay, well, hopefully this talk will, have you put a few more hands up in the future. So I wanted to start off with a little bit of background. First slide, I'm going to talk a little bit about Node.js, but this is a Deno talk. So Node.js has been around since around 2009, and it actually predates much of what we consider to be modern JavaScript. So if you've ever used Node, you're probably familiar with CommonJS. There's now support for ES modules, but there's still a lot of CommonJS out there, still a lot of Node APIs that use callbacks instead of promises, and things like that. And I guess historically, Node had a very kind of minimal core philosophy. So a lot of what you wanted to do was kind of left up to your own devices. You had to go to npm, find modules to install, things like that. And Node has kind of developed this huge ecosystem in the process, but that's both good and bad. So it's nice to have a lot of users, but that huge ecosystem can actually slow down progress because there's a lot of backwards compatibility concerns and things like that. Legacy code that's no longer maintained because the maintainers have moved on to do other things. So that can really slow down progress and especially hinder things like standards compliance. So a lot of people have complained about that. And then back in June of 2018, there was actually a talk given at JSConf EU that introduced Deno, which was kind of the goal of Deno was to kind of address some of the perceived shortcomings of Node.js. So Deno started, it was announced in June of 2018. By August of 2018, Deno 0.1.0 had been released. And this release was significant because Deno had been rewritten in Rust. So, obviously there's the JavaScript and TypeScript side of things, but then there's a native layer underneath. And originally that had been written in Golang. But having two kind of garbage collected languages inside of the same process might not be the best thing. So it was kind of decided to rewrite everything in Rust. Fast forward to May of 2020 and Deno 1.0 was released. A little bit after that, in March of 2021, the Deno company was announced. So the little graphic in the corner here has all of the Deno employees working while the little tiger, which is supposed to be Ryan Dahl, sits on the couch and relaxes. And then a little bit after that, Deno Deploy was announced in June. And so Deno Deploy, I'll talk about a little bit later, but it is kind of the cloud extension of having a JavaScript runtime on your local machine. And then Q3 of 2022, which obviously has not happened yet, is when Deno Deploy is expected to reach general availability. So I wanted to talk a little bit about how Deno has grown since it's been announced. So I have a chart here that shows a graph of GitHub stars over time for both Node.js and Deno. So for some reason, the chart would only go back to 2015. Node has actually been around longer than that. But you'll see that Node had a pretty substantial head start on Deno, and Deno has pretty rapidly caught up with GitHub stars at least. Now that is just, GitHub stars are kind of a proxy metric for usage and adoption. Anybody can stop by the Deno repo, put a star on it, and never use Deno again. We do have some internal metrics at the company though that indicate that this is not just baloney. Usage is actually growing like this. Yeah, so take it for what you will, GitHub stars, but I think it's promising at least. So the next thing I wanted to talk about was kind of the core technology comparison between Deno and Node. Both of them are built on top of a JavaScript engine. That JavaScript engine is going to be V8, the same JavaScript engine that is inside of Google Chrome and just about everything else these days. But then from there, things just kind of pretty much diverge. So like I said, Deno is now written in Rust at the native layer, while Node.js is written in C++. C++ is the natural choice for the language there because V8 is written in C++, so it kind of fits together nicely. So I'll talk in a minute about how we have the Rust layer surrounding C++ in Deno. Next is the async I/O layer. So if you've used Node, this is going to be libuv. That's where Node gets its asynchronous I/O, its event loop, a whole bunch of other cross-platform things. Since Deno is using Rust, it makes more sense to use a lot of Rust dependencies. So Tokyo was chosen as the layer there. For TLS and crypto, Node uses OpenSSL, Deno uses Rust TLS. HTTP layer, Node uses LLHTTP, Deno uses Hyper and Request, depending on whether you're the server or the client. The DNS layer, Deno uses Trust DNS, while Node uses C-Aries. And then there's going to be other dependencies throughout there as well, but those are kind of the major players. So now I wanted to talk a little bit about Deno and its Rust and how it wraps C++. So Deno is actually built from a lot of individual Rust crates, and that is by design. So the idea is that you can take all of these open source Rust crates and kind of mix them and match them however you want to. And if you were really feeling spunky, you could actually roll your own VM based on all these crates. Deno Deploy is kind of an example of that. It's built off of all the same things as the open source project, but there are some tweaks under the hood to make it better suited for running in the cloud. So as I mentioned earlier, V8 is a C++ project. It's kind of nasty to deal with. So we came up with a layer surrounding that called Rusty V8. Rusty V8 is a Rust crate that kind of encapsulates all of the C++ for you. It also has the nice side effect of allowing you to install without having to build V8 from source. If you've ever tried to build V8 from source before, it can take a really long time. Depending on what type of computer you have, your fan and heat sink will not like you very much. But yeah, so that is kind of the encapsulation layer for the C++. Everything else outside of this is going to be Rust code. And then there's also a layer called the Deno ops layer, which more or less provides an API for performing operations with Rusty V8 and things like that. And then all of that is kind of wrapped up inside of what's called the Deno core Rust crate. So the next layer up, because this is a multi-layered architecture, you'll see we still have the Deno core layer here, but it's now wrapped in another crate called the Deno runtime. So the Deno runtime is a more complete JavaScript implementation. So you can, technically you could run JavaScript with Deno core, but it'll be a lot more involved. So the Deno runtime abstracts a lot of those things for you. This also brings Tokyo into the mix, so this is where you'll start dealing with the event loop and async I/O and all of that. And then on the right-hand side of the image here, there are a bunch of crates that are used to implement various APIs, like Deno Web, for example, implements web platform APIs. Deno Fetch implements Fetch. Deno Cryptos for crypto, etc. So I didn't list them all here, but that's kind of the big picture. So we were just talking about Deno runtime. Now we move one layer up to the Deno CLI. So this is what you would actually download and run your JavaScript and TypeScript applications with. So it is distributed as a single executable. It's fairly small for everything that's inside of it. It's always going to be distributed as a single executable. It has a lot of other things built in with it, an integrated toolchain, which I'll talk about in a few minutes. And the idea is that Deno is very much batteries included compared to historically Node.js, which was not. And so the idea is that you'll be able to have everything that you'll ever need to be able to build and run and deploy Deno applications. So we do currently support the big three operating systems, Linux, Mac OS, and Windows. And then I have a link down at the bottom if you're interested in installing and kind of getting started with Deno. So the next thing I wanted to talk about is Deno's standard library. So if you've used Node.js, this is going to be similar to the core modules, FS, HTTP, and all of those. These are modules that are maintained and audited and vetted by the Deno core team to make sure that they do work with Deno, that there's not going to be anything like the colors.js debacle where all of a sudden things are going to start Zalgo bombing your machine and things like that. So these are all considered modules that are going to be safe to use. They have all of the important functionality that you would need to build your applications, FS, HTTP, streams, UUIDs, WASI implementation, and things like that. So you can go to deno.land/std to see the latest version of these. It's got a nice kind of like GitHub style interface where you can click through and look at all the code and see all the different modules. But this link will redirect you to whatever the latest version of it is. So if you're going to be using these dependencies inside of your code, we do recommend pinning to a specific version so that if there are breaking changes or unintentional breaking changes, that your application will continue to work. So the little snippet here at the bottom has an example of how you would go about doing that. So you'll see instead of deno.land/std, I've now added the @0.141.0 specifier. So this means that you're getting that specific version, and then we're importing fs and then mod.ts. And so I'm importing the copy function from there, which will let you copy files and directories around on your local machine, and then you can just use it as you would any other JavaScript code. So one nice thing about having the standard library separate is that it can be versioned independently and maintained independently. Right now, it is released every time there's a new release of the core project. So you can, like I said, always count on these being up to date and working. So next I wanted to talk more about dependency management, but instead of the standard library, kind of the user land side of things. So it's going to be a lot like working in a browser. There's no NPM. There's no common JS, it's ES modules only, no package.json, no node modules folder, there's no magical index.js, so if you just require a directory, it's not going to really know, it's not going to look for this magical file and import it for you. And it's really nice to work with because if you've ever used Rust before, Rust kind of will fetch and install things for you kind of behind the scenes when you want to run your code. And I think Deno kind of took a page from there. So you don't have, there's no separate like npm install and things like that. And if you're doing this in production, you probably want to make sure that your dependencies are managed properly for you. So we have a command called Deno vendor, which will actually download all of your dependencies locally, and then you can manage them however you need to, whether that's checking them into source control or things like that. So then at the bottom of the screen, I have the same snippet from the last slide. We actually have, it's not necessarily npm, but there is a hosting for modules. It's deno.land/x. And so it's the same kind of idea where you can go there, there's a web interface, you can look at all the different modules that people have published and browse them and things like that. And it works the same way as it would with the standard library. So if you wanted to download and install Deno and keep up to date, there are weekly patch releases. There's also a monthly Semver minor release. These releases normally happen on Thursdays, so hopefully you won't update over the weekend and have things break and get paged. There are occasional Semver major releases. We're currently on the 1.0 release. No current timeline for when 2.0 will happen, but there are occasional releases. And there's not really a long-term support schedule yet, although that's something that I think is in the works. So I guess what does a basic Hello World application look like? Here's an example. So at the very top, I'm importing the serve function from the standard library's HTTP module. Then I have a handler function. This is going to be TypeScript, so you'll see we have _rec. That's going to be the incoming request. It's prefixed with an underscore because we're not actually using it here. And then this function is going to return a response for you that just says hello world. And then you just call the serve function with the handler that you defined. Whenever you call that, it'll actually start up a server for you. It'll print out which port it's running on. I think by default it's port 8000. And then it'll just serve traffic for you. And if you actually wanted to run this code, assuming that you put it into a file called server.ts, you would just run deno run allow net server.ts. I'll explain in a minute what allow net means. So I guess what are some of the killer features of Deno, at least in my opinion? The first one is a really strong focus on web platform compatibility. So there's not going to be a bunch of kind of one-off APIs that Deno kind of defines. There is a global Deno object, which we keep all the custom stuff under instead of polluting the global namespace and having a ton of one-off modules. So the Deno prefers web platform compatibility wherever possible. There's an integrated tool chain, which I'll talk about in a minute. As I showed in the last example, TypeScript is supported out of the box. I'll talk about that a little bit more. Permission system, which is what the allow run was on the previous slide. I'll go into that in more detail. And because Node.js is so just everywhere and has such a huge ecosystem, there is a Node.js compatibility layer, which will actually help you if you wanted to run Node.js code or port your Node.js code over to Deno. So on the note about web platform compatibility, as I said, Deno does prefer to use web platform APIs wherever possible. I have a table here that shows a number of the APIs that are supported. There are even more than this, but they wouldn't fit nicely on a slide. And then Deno is also listed in the Mozilla MDN browser compatibility tables. So if you look at the far right, the last two columns here, you'll see Deno and Node.js side by side. So this particular example is for set timeout, and you'll see Deno has full support for set timeout since version 1. Node.js has supported set timeout for years as well, but is not standards compatible. So Node.js returns a different type of object than what the standard calls for. It doesn't allow code strings to be passed in and things of that nature. Next, I wanted to talk about the tooling comparison. So as I mentioned, Deno does have an integrated tool chain. All the things you see here in the left-hand column come out of the box. So you don't have to install a linter, formatter, version manager, any of those things. If you were using Node, you would have to separately install ESLint, Prettier, MVM, all the things that are listed here. The one thing that Node does have out of the box is a test runner. The test runner was just added in the most recent version of Node.js, so it hasn't been around for long. And it was only really added to to Node because Deno had it, so it kind of opened the door to add one to Node. So there's all this functionality that's kind of built in for you. If you ever, this is not an exhaustive list. If you wanted to see everything, just run Deno -- help. It'll print out a full list of all the subcommands, and you can kind of see what they all do. Next, I wanted to talk about TypeScript support. So, like I said, TypeScript is supported out of the box. There's no separate compile step, at least not one that you have to manage yourself. The TypeScript compiler is actually snapshotted into the Deno executable. And then SWC, which stands for the Speedy Web Compiler, it's a Rust tool for doing basically what Babel would do for you, except it's, I think it's 20x faster with single-threaded execution, and I think up to 70 times faster, multi-threaded. So it's a lot faster than Babel. So we use all of these things to kind of type check and transpile and bundle up your TypeScript code for you. And then all of this stuff is actually cached locally, so it won't have to recompile everything unless it's necessary. And then if you have a lot of custom TSC options that you need to set, you can actually do that with a config file. It's not generally needed, so we don't really recommend it, but the support is there if you need to. Next up, I wanted to talk about the permission system. So by default, Deno is more or less sandboxed. It can't access the outside world, the file system, the network, things like that. So you have to explicitly grant permission for anything that you want to grant it permission to do. So I have a list of all of the CLI flags here on the right-hand side. So -- allow env will let you access environment variables. HR time will let you access high resolution time. The reason that is behind a flag is because it actually can open you up to various timing attacks. Not something you generally have to worry about, but it is nice to have it sandboxed anyway. Allow net lets you access the network. FFI lets you load dynamic libraries. Allow read and allow write are for accessing the file system. And then allow run is if you want to actually be able to spawn sub-processes. And then if you just, if you don't care about the permission system or if you're just doing local development, you can specify allow all, or the shortcut is -A, and it'll just let you, do whatever you want. So I guess one thing to note about the permissions is if you're using this with dynamic libraries or child processes, these permissions are not going to be inherited. So if you spawn a process, it's going to be able to do whatever it wants. It's not going to be under the same constraints. And then you can actually further lock down the process while still granting permission if you wanted to. So for example, if I wanted to do read or write, but only to a specific directory, you can actually pass that as part of the allow read or allow write flag, and it'll just kind of take care of sandboxing to that directory for you. And then these permissions do apply to the entire process. So if you import a dependency, you can't lock down that dependency individually, at least not at this point in time. Next, I wanted to talk about the node compatibility layer. So on the right here, I have a graph of various module ecosystems. The one that is way above all the other ones is NPM. So there's a ton of code out here, and it doesn't make sense to leave all this perfectly good JavaScript code on the table. So Deno added a Node.js compatibility layer, which you can access with the -- compat flag. It is still listed as an unstable feature technically, so you'll need the -- unstable flag. And if you want to use any common JS, like the require function to read from the file system, you will need to specify allow read. But then the code example here is just taken from the docs. It lets you import the Node.js compatibility module with a create require function. You use that to create your own require, similar to how Node gives you. And then you can require path, you can require local files, you could even require left pad if you really wanted to. So then I wanted to talk about some of the more recent changes. I'm not going to go into all of these in detail, but we keep V8 up to date. I think it's currently at 10.3. The web crypto API has been finished after I think it was like 6 months of work. Mocking and snapshots have been added into the built-in test runner. A number of new CLI subcommands, task, bench, vendor, all these nice subcommands have been added. And then at the bottom here, I have response.json. So this was something that was added to the fetch specification by the Deno team. And it was done specifically with the server-side use case of fetch in mind. And so that is important because there is a new W3C community group called the Web Interoperable Runtimes Community Group, also known as WinterCG. So this is a collaboration between various non-browser JavaScript runtimes. A number of the logos are shown at the bottom. That's not all of them, but that's what's currently on the website. So this group is not aiming to create a bunch of new APIs, but kind of give a voice to server-side runtimes at the table where all this discussion about specifications happen. Historically, servers have been kind of a second-class citizen. I think that has changed a lot recently, but I'm hopeful that with this new WinterCG, that will be even more the case, that server-side runtimes are really considered. So there's a link to the blog post here if you wanted to go read more about it. And then not shown on the slide here, but Deno is also a participant in TC39, which is the standards body that actually defines the JavaScript, or I guess ECMAScript programming language. Then I wanted to mention Deno Deploy really briefly. This is not a product pitch, but this is a Deno product. It does have a generous free tier if you wanted to go play around with it. It is essentially a globally distributed JavaScript VM. So it's basically a V8 isolate cloud. Think something similar to Lambda functions, but at the edge. We're currently in over 30 regions and continuing to grow as new regions are brought online. It's built on all of the same open source crates that I talked about earlier in this talk, with kind of tweaks to make them better suited and more fun in the cloud. So what if broadcast channel was a global message bus, or what if local storage or IndexedDB was able to actually persist your data in the cloud for you. And Deno Deploy is integrated with both netlify functions and Supabase functions. So there is usage out there. It's currently in beta, but hopeful to bring that out of beta by the end of the year. And then I have a collection of kind of what I consider to be important links, documentation, the standard library, the third-party module registry, all of the different source code. There is a community Discord if you wanted to join and ask questions there. It's very active. And then the link here if you wanted to try out Deno Deploy. Like I said, it has a very generous free tier. And that is everything. Thank you for coming.